In other news, tech giant Nvidia today became the first company to reach a market value of $5 trillion.
Nvidia.
Come on, where does Bill Gates sit on quantum computing? You know, Nvidia CEO Jensen Huang talking about.
How did this three-man startup from a diner booth become a $5 trillion titan redefining technology itself? From a company no one could pronounce to the name behind every breakthrough in gaming, AI, and beyond. This is the story of Nvidia and how it changed everything.
Welcome back, everybody. Jensen is here, of course, the CEO of Nvidia. This is the clear winner of every winner in the world of artificial intelligence.
Today, Nvidia stands among the most valuable and influential companies in the world. Its technology powers nearly everything digital, from high-end video games and movie visual effects to artificial intelligence systems, autonomous vehicles, and massive data centers that run the modern internet. But Nvidia's story didn't begin with AI or trillion-dollar valuations. It began in the early 1990s, when three engineers believed computers could do far more than anyone expected. They set out to make games look more realistic and ended up changing the future of computing. Nvidia was founded in 1993 by Jensen Huang, Chris Malachowski, and Curtis Preem in a corner booth at a Denny's in San Jose, California. All three were experienced chip designers. Huang had worked at LSY Logic. Preem came from Sun Microsystems, and Malachowski was an engineer at IBM. Together, they shared a vision that personal computers could become powerful visual machines, capable of creating images that felt lifelike and immersive. At the time, graphics hardware was limited. Most computers handled 2D visuals and basic color rendering. Games were pixelated, blocky, and slow, so the founders saw a gap in the market, a chance to build a chip dedicated entirely to graphics performance.
So what we were trying to do as a company was to invent a new way of doing computing that solves problems that normal computers can't. Nobody wants to go to where problems can't be solved. And so where we are was rather lonely. You know, there aren't other people solving this problem because it's hard to solve. There aren't many customers because they tend not to choose problems like that. They want to have their problems be solvable, not unsolvable. Over time, the reason why it took us so long is because it's hard. And the reason why we're here alone is because people left us alone for a long time.
That chip would later become known as the GPU. Their first product, the NV1, launched in 1995. It was ambitious for its time. It could render 3D graphics, handle audio, and even connect to a game controller. But it didn't align with the direction of the gaming industry. Developers were moving toward a graphics standard called DirectX, and the NV1 wasn't compatible. The product failed, and the company nearly ran out of money. Still, Nvidia learned a key lesson. In technology, success doesn't always come from having the most features. It comes from building for the ecosystem. That idea would define their strategy for decades to come. By the late 1990s, 3D gaming was exploding. Titles like Quake and Tomb Raider were pushing computers to their limits. Developers wanted hardware that could handle realistic lighting, shading, and motion. Nvidia saw its moment. In 1999, they introduced the GeForce 256, the world's first GPU, or graphics processing unit. It could perform millions of mathematical calculations per second, taking the burden off the CPU and enabling true real-time 3D rendering. Games suddenly looked smoother, faster, and far more detailed than ever before. It was a revolution in visual computing. That same year, Nvidia went public on the NASDAQ stock exchange. Its market capitalization was about $1.5 billion, small by today's standards, but a major achievement for a 6-year-old startup. The GeForce brand became a symbol of high-performance graphics, and Nvidia began releasing a new chip architecture almost every year. Each generation improved performance, power efficiency, and visual realism, but competition was fierce. Rival companies like ATI and 3DFX Interactive were fighting for dominance. Each one pushed new technologies, higher resolution, more textures, faster rendering. The race for better graphics turned into a war of innovation. Nvidia emerged as the winner, partly because of its software. It didn't just sell chips, it built tools for developers. Its driver updates, SDKs, and partnerships with game studios meant that Nvidia cards consistently performed better in real-world games. By the early 2000s, the company had become the go-to name for gamers and game developers alike. In 2006, Nvidia made a decision that would redefine its identity. The company introduced CUDA, short for Compute Unified Device Architecture. CUDA allowed programmers to use Nvidia GPUs not just for rendering images, but for performing general-purpose computations. This meant the same hardware that drew 3D graphics could now process large-scale datasets and complex algorithms. At first, the idea seemed niche, but CUDA quietly opened the door to new industries. Scientists began using GPUs to model climate systems, simulate molecules, and analyze genomes. Researchers realized that GPUs could perform thousands of operations simultaneously, something CPUs weren't designed for. That ability to handle massive parallel workloads would soon become essential for artificial intelligence. In 2007, as the world was just beginning to understand the potential of parallel computing, Nvidia's value hovered around $13 billion. A decade later, after years of steady growth, it had crossed $100 billion. But its biggest leap was still ahead. In the early 2010s, a new wave of AI research began to rise. Deep learning, neural networks once dismissed as inefficient, were now showing incredible potential. But they required immense computational power. Training these models on CPUs could take weeks or months. With GPUs, it took days. And Nvidia was the only company with mature, programmable GPU hardware and a robust developer ecosystem ready to support it. Suddenly, Nvidia chips became indispensable to AI labs around the world, from universities to major tech companies. Researchers relied on Nvidia GPUs to train neural networks capable of recognizing images, processing language, and even generating human-like text and art. This shift marked the company's transition from a gaming brand to a leader in high-performance computing. Nvidia's data center business grew rapidly. Its DGX systems combined dozens of GPUs into powerful clusters specifically optimized for AI workloads. The company launched new architectures, Pascal, Volta, Ampere, and Hopper, each one offering exponential gains in performance. Meanwhile, its gaming division continued to thrive with products like the RTX series, introducing real-time ray tracing and AI-enhanced graphics. Nvidia had managed to dominate both the consumer and enterprise markets at once. As artificial intelligence began to reshape industries, Nvidia's influence expanded. Automotive companies adopted its Drive platform to power autonomous vehicles. Medical researchers used its chips to process MRI data and simulate protein structures. Financial institutions used GPUs to model risk and detect fraud in real time. Everywhere data needed to be processed fast. Nvidia hardware became the engine behind it. By 2020, Nvidia's market cap had climbed to around $328 billion, more than 200 times its value from its IPO 2 decades earlier. At that point, it was no longer just a hardware manufacturer, it was a full-stack computing company. It sold chips, yes, but also the software frameworks that made them useful. CUDA, TensorRT, Omniverse, and more. The company's reach extended into cloud services and virtual collaboration, positioning it at the center of the next wave of digital transformation. Then came the generative AI boom, when tools like ChatGPT, Midjourney, and Stable Diffusion exploded in popularity. They all shared one thing in common. They ran on Nvidia GPUs.
I was there with Elon Musk, Jensen Huang, and I went to dinner. And I would describe the dinner as Oracle and me and Elon begging Jensen for GPUs. Please take our money. Please take our money. By the way, I got dinner.
Demand surged so fast that data centers around the world began running out of supply. The company's revenue and stock price soared. In 2023, Nvidia's market capitalization briefly surpassed $1 trillion.
How
milestone day for Nvidia. Tuesday, the company became the first chip maker to reach $1 trillion in market value. It joins an exclusive club with members including Apple, Google parent Alphabet, Microsoft, and Amazon. Nvidia is benefiting from the surge in demand for chips for artificial intelligence applications, including for chatbot sensation ChatGPT. Last week, it stunned investors with a revenue forecast that surpassed analysts' expectations by more than 50%. Wall Street analysts called Nvidia's outlook unfathomable and cosmological.
Behind it all was Jensen Huang, the company's co-founder and CEO. Known for his signature black leather jacket and relentless energy, Huang built Nvidia around a single principle: that the future of computing would be accelerated, parallel, and intelligent. Under his leadership, the company never stood still, while others optimized for the present. Nvidia kept building for what was coming next. By late 2025, Nvidia's valuation had crossed $5 trillion, making it the most valuable company in human history. Today, Nvidia's technology is at the core of nearly every major AI development. Its GPUs run in supercomputers, research labs, and cloud services across the planet. They power the training of large language models, the rendering of virtual worlds, and the simulation of physical systems used to design the next generation of robots and vehicles. In many ways, NVDA has become the invisible backbone of modern innovation. Every photo recognized by an algorithm, every self-driving car analyzing its surroundings, every AI model generating an image or a sentence. Somewhere, a GPU is doing the work. From a small team in a rented office to one of the most powerful technology companies on Earth, NVIDIA's journey reflects how fast computing can evolve when vision meets timing. It started with pixels and polygons, but ended up powering intelligence itself. What began as a company built for gamers now fuels the future of science, art, and automation. NVIDIA's story isn't just about hardware or software. It's about transformation. A transformation of how we create, compute, and communicate. And as artificial intelligence continues to expand, one thing is clear. The same company that once made games look real is now helping machines understand reality.